Let's consider the next problem wherein y of n is equal to minus of alpha raised to n u of minus n minus 1. So when we are given with this kind of a problem, how to solve? Let's see. We are given with x of n is equal to minus of alpha raised to n u of minus n minus 1. Now we write, let's say y of n or x of n, it doesn't matter. So x of z is given by x of z is equal to summation n from minus infinity to plus infinity. That's right. We write this equation of x of z, the z transform equation we write, and let's substitute the value of x of n. So x of n is minus of, minus we can take outside, minus of alpha raised to n u of minus n minus 1. So let's write it as u of minus n minus 1 into z to the power minus n as it is. We know that u of minus n minus 1 signal. So we first to draw what is u of n signal. We know u of n signal is from 0 to, so there is a sample, there are samples at these places at 0, 1, 2 and so on up till infinity. Then u of n minus 1 is the signal which is having, which is starting at 1. It is not having the sample at 0. So it is this kind of a signal. But from 1 it is beginning. So the samples begin from here. And u of minus n minus 1 means it is the time reversed signal of u of n minus 1. When u of n minus 1 is time reversed, then we are getting u of minus n minus 1. So which looks in this fashion. So if we go for drawing it, so that signal will be in this fashion. It will be having its sample at minus 1, at minus 2, minus 3 and so on up till minus infinity. So the signal is running from minus 1 to minus infinity. It is not having the sample at 0, at 1, 2 and so on. So this is a left-handed sequence. So let's go for its solution. So, and the summation will not run from minus infinity to plus infinity because the signal is not there from 0 onwards. So let's write this equation n is equal to minus infinity as it is because the signal is existing at minus infinity. So we are having the samples in this way, and this highest value would be minus 1 and alpha raised to n, and this has already been taken into account in the summation. So we write z raised to minus n. Then we can go for solving it. Of course there is a minus sign, so let's write the minus sign, summation n from minus infinity to minus 1. This is, let's write this one as alpha into z raised to minus 1. Similarly, z raised to minus 1 raised to n. So we can write in this fashion. Now we don't have the summations, like we don't have the solutions of such kind of summations. Only we have the equations which can give the solutions for the positive limitations, the positive limits. Means this summation has to have its limits, its upper and lower values. Limits have to be positive. Then to make this one, to make this summation a positive term, so let's let n is equal to minus n. So let's write that our n is equal to let. When n is equal to minus n, means wherever there is n, we go on making that one as minus 1. Means this equation will have its negative sign as it is. Now let's look at the summation. Now here positive n is there, it becomes negative. So let's write this one as minus n now. So when this is minus n is equal to minus infinity, just we are making n as minus n and this one as minus 1, but we know that it is for minus n, and alpha into z raised to minus 1 raised to minus n it would be. Then to solve this, we know that it is minus n is equal to minus infinity, so which is nothing but n is equal to infinity. So we write this one as infinity, and this becomes 1, and minus sign as it is, alpha z raised to minus 1 raised to minus n is there. So we don't want minus sign, to make this one as plus. So let's multiply all these powers by minus 1, or we can say we write in this fashion, alpha raised to minus 1 and z we write. So it is, by considering minus 1 is being taken outside, this becomes n then. And after writing it in the proper fashion, because always the higher limit has to be written at the top, so our n will be 1 to infinity, minus sign as it is, and this solution we need to write, or writing the summation, let's write it. It is alpha bracket alpha raised to minus 1 into z raised to n. So which will be given by, now to solve this equation we need to set up a condition. So what is the condition? Consider that this alpha raised to minus 1 into z is less than, alpha raised to minus 1 into z is less than 1. So by considering this, we approximate this equation as it is 1 divided by, now but you could have written it as 1 divided by, but the summation starts with 1. If it is starting with 1, then this value has to be written. If it is 2, then the square of this in this fashion. So it is alpha raised to minus 1 into z divided by 1 minus alpha into alpha raised to minus 1 into z. So let's write it properly. So 1 minus alpha raised to minus 1 into z. So no need to use the bracket also. And when we simplify, this becomes z by alpha, again z by alpha, and there is a minus sign also, which makes this as z divided by z minus alpha again, but it is z divided by z minus alpha. So let's write it properly, z divided by z minus alpha. It's z divided by z minus alpha, but with this condition, and this condition can be written as it is 1, it is z by alpha we can need to write. So magnitude of z, magnitude of alpha raised to, this implies that z has to be less than alpha. So magnitude of z is less than magnitude of alpha, which means the z, if we go for drawing the region of convergence, we need to draw a circle with radius alpha, and let's say this is the circle with radius alpha. Then if the z means entire plane, but if that z is less than alpha, then this equation is solvable, otherwise no. Means if the points are within the circle, then the equation becomes solvable, and if they are outside of this, then the equation becomes unsolvable, so it cannot be solved. So for that reason, we represent the arrow C in this fashion. The arrow C is inside the circle and it is not the outside. And the conclusion after solving is, for right-handed sequences, means if the sequences are in the right fashion, just like the previous alpha raised to n u of n was a right-handed sequence, and for which the ROC is outside the circle. But for a left-handed sequence, now this is minus of u raised to minus of u of minus n minus 1 is a left-handed sequence. So for this, ROC is inside the circle. And if we represent the poles and zeros, there is a pole over here at alpha, and there is a pole over here, and there is a 0 at this. So it is a perfect circle. Then this is regarding the solution of minus of alpha raised to n u of minus n minus 1, which shows in this way. Similarly, it has been solved but with a different method, but I hope this one, the solved one, you have understood. And ROC is inside of the circle rather than outside for the right-handed sequences, but it is a left-handed sequence, it is inside. Now similarly, let's see the next problem. The next problem is this way. So let's see how does this works. Here the problem is x of n is equal to minus of u of minus n minus 1 plus alpha raised to n into u of n. Then how this has to be solved? Then see. So the ROC of this we need to find also. We need to find the solution as well as the ROC has to be re-indicated. And clearly we know that minus of u of minus n minus 1 is a left-handed sequence, and alpha raised, this half raised to n, just like alpha raised to n u of n is a right-handed sequence. Now we go for writing the Z transform equation. The summation, the x of n's value is substituted. First this one is written, half raised to n u of n z raised to minus n, and minus of u of minus n minus 1 into z raised to minus n. And we know that this is, it can be written as this u of n is there, it makes it as 0 to infinity, and 1 by 2 as it is. Now instead of writing z raised to minus 1, even we can write it as 1 by z also, as per the convenience. 1 divided by 2z also we can write, or z to the power minus 1 is also fine, raised to n. And the second one is minus as it is. From this it is summation, and from minus infinity to minus 1, just the previous problem how we have solved. It is just 1 divided by nothing is like there. So x of n's value is 1 only, but z to the power minus n, so that will make it as z to the power minus 1 raised to n. And when we go for its solution, so we know the solution of this alpha raised to u of n as 1 divided by alpha 1 divided 1 by 1 minus alpha into z raised to minus 1. In that way it has to be solved. So we write this in this fashion, and to make this one, or straight away we'll go for writing its solution. So 1 by 2 z, which will be 1 by 1 minus, like alpha value is 1 by 2. So if we take 1 by 1 minus alpha z raised to minus 1. Similarly 1 by 2 it is. And if we go for its solution, so this will be with the same methods we have, so which can be written as n is equal to 0 to infinity. Let's write this one as it is 1 by 2 z raised to minus 1. Let me write raised to n, because the z to the power minus n gets applied to both of these. And similarly minus of this summation, and the summation runs from minus n is equal to minus infinity to minus 1. Again minus infinity to minus 1, alpha raised to n. This u of minus n minus 1 is being taken care of here. It is z to the power z to the power minus 1, and let's write this one as alpha and z to the power minus 1 raised to n. And we have solved the second problem. By using that, we can approximate, this remains as it is. The second one can be approximated as it is summation n is equal to, let's write 1, because when we take n is equal to minus n here, so only for the second term, when n becomes, we can take in this fashion, when n is equal to minus n in this second, then it becomes 1 and infinity. Let's write the lower limit, the lower value first, and then upper one, and it is alpha z to the power, so alpha raised to minus 1, because n has gone to minus n, so it will be in this fashion. And this remains as it is. It is a summation from n is equal to 0 to infinity, summation. And for this we can write this 1 divided by 1 minus alpha into z raised to minus 1. So by considering that, it is 1 divided by 1 minus half raised to, it is half into z raised to minus 1. We'll write, and minus, for this we need to write as n is from 1 to infinity. This becomes, now here alpha is there, as our problem is not having the alpha, it is just minus u of minus n minus 1. So we need to write it as, so there is no alpha here. Let's consider alpha is 1, then z raised to minus 1 we get, and it goes to z to the power n. So when we write, it is simply z to the power n. Then this equation can be approximated as z divided by 1 minus z with a minus sign. So when we go for its solution, it can be written as 1 divided by, now when we solve, this becomes 1 by 2 z, and this z can be taken on this side, 2z minus 1 it could be, divided by 2z, and 2z can be taken above, so 2z divided by 2z minus 1, it would be this equation, and this can be written as, let's write plus z divided by, let me write this one as z minus 1. So when we go for its solution, so it is simply 2z minus 1 or z minus 1 by 2 into z minus 1 again the multiplication of these two will get, and we can write this one 1 by 2 z raised to minus 1 raised to n as this one if and only if there is a condition that 1 by 2 into z to the power minus 1, if it is less than 1, then only we can write this solution, otherwise no. And similarly we can approximate this one if z is less than 1. If z is less than 1, then only we can approximate the second equation to this, otherwise it will not be. So it is 1 minus. So we have this as 1. And solution of this gives, it is 1 divided by 2z, means 1 by 2 into magnitude of z is here is less than 1, which implies that 1 by 2 is less than magnitude of z. When z is greater than 1 by 2, or when z is greater than 1 by 2 or 1 by 2 is less than z, and even another condition is when z is less than 1. When z is less than 1 means the ROC has to be in what way? Let's see. So let's draw this, and we need to draw the two circles with radius 1 by 2 and 1. Let's draw a circle with radius 1 by 2 first, and let's draw another circle with radius 1. Let's say this is the circle with radius 1, and its radius is 1 and its radius is 1 by 2. And as per this, we have z into 2z minus 3 by 2 after solution, z minus 1 by 2, z minus 1. So the zeros of this equation are z is equal to 0 and z is equal to 3 by 4. So let's represent z is equal to 0 and z is equal to 3 by 4. So z is equal to 0 means here it would be, there is a 0 at z is equal to 0, and at 3 by 4. 3 by 4 means 0.75, which will be in between. So you will be having the pole in between these two. So it is these two. It is 3 by 4. So let's write properly. It is 3 by 4 and it is 0. And let's see the other ones. What are they? The poles are at z is equal to 1 by 2, means there is a pole at this place and at this place at 1. These are the pole locations. The poles are lying at these places. Now if we go for ROC, the first condition is z has to be greater than 1 by 2, means it should not be inside of this circle. If we take a point inside of the circle, then z would be less than 1 by 2, means ROC is outside of this circle. Okay, it is outside, let's say. Then what about this condition? When z is less than 1, means it has to be inside, means the ROC is in between these two circles. The ROC is in between these two. So we can represent in this fashion, and this is our ROC when we have two types of signals. I mean when we have a right-handed sequence and a left-handed sequence. When two types of signals are there, one is left-handed and another one is right-handed, then depending upon the values of the circles, means depending upon the values whose power is n, so depending upon those, the ROC would be inside or outside in this fashion. So it may be within these two circles, or even it may be the situation wherein it would be inside of the circle and even outside of the circle, except the region where the ROC is right now. So I hope you are getting. And one more thing we can notice that in the problems, the poles are not included in the ROC region. The zeros are there. Now here 0 is there at 3/4, which is the ROC region, but 1/2 and 1 are the boundary points. The ROC doesn't contain any poles. Is also one of the property of region of convergence. So let's see the next one. So this is the property, this is the problem, and we can see the next slide, and ROC is inside of this. Another problem is when x of n is 1, 2, -1, 1, 0, then in these kind of problems where it is just like a discrete signal, we can represent a discrete signal. At n is equal to -1, there is a sample of 1. At n is equal to 0 means when it is given in the form of a sample signal. When n is equal to 1, it is -1. Just if it is there, then we need to take up x of z equation, and in that x of z equation, let's write our range. Now our range is from -1 to 2. So we need to write -1 to 2. So x of -1, z to the power n it is. Now our n is -1, so z to the power 1 it would be. X of 0, z to the power 0. X of 1, z to the power -1. X of 2, z to the power -2 similarly. And when we substitute the respective values of x of -1, -2 and all, so when we substitute, x of -1 is 1, x of 0 is 2, x of 1 is again -1, x of 2 is 1. So when we write these, we get it as z plus 2 minus z raised to -1 plus z raised to -2 in this fashion. The other kind of problems, we can see these kind of problems in the next classes.